Chapter 1. The Artificial Intelligent. ThinkBot. Jia. Jia, hey, how does YouTube always seem to know exactly what videos I'd like? ThinkBot. Hi. YouTube uses algorithms to suggest videos. When you watch and search for things, it learns about your interests and predicts what you might enjoy. Jia, wow, so it's like a robot is keeping track of everything I do on the platform? ThinkBot, not exactly a robot, but yeah, a complex system tracks your activity. It just knows your preferences based on what you do on YouTube. Jia, that's a relief. But how does it figure out what to suggest? Sometimes it's like they read my mind. ThinkBot, haha, it can feel that way. The system looks at your watch history, searches, and even what videos you like or dislike, compares your actions to other users who enjoy similar stuff, and suggests videos those users found interesting. Yeah, that's both really cool. But does it ever get things wrong? Sometimes I'm like, why would I want to watch this? ThinkBot, absolutely, it's not perfect. Sometimes the algorithms make mistakes or misunderstand your preferences. You can always help by giving feedback like thumbs up or down so YouTube can learn better. Jia, got it. It's like I am teaching the machine what I like. Thanks for explaining this to me. ThinkBot, exactly. You're welcome. Jia, thanks. I am really curious now about all this. ThinkBot, well, in that case, let me help you in understanding all of it from the start. History of Artificial Intelligence. The journey of AI has been a transformative trajectory marked by exponential growth and innovation. Beginning with theoretical foundations in the mid-20th century, AI's initial steps focused on symbolic reasoning and problem solving. The field experienced periods of excitement and disillusionment, known as AI winters, as early expectations collided with limitations in computing power and algorithm complexity. However, breakthroughs in machine learning, particularly deep learning, revived AI in recent years. This revolution harnessed the potential of neural networks, enabling AI systems to learn from vast datasets and excel in tasks like image recognition, natural language processing, and game strategy. AI's journey has transitioned from theoretical speculation to practical application, impacting industries from healthcare to finance and transportation, and shaping a future where intelligent machines collaborate with humans in new and remarkable ways. 1642. First mechanical calculating machine built by French mathematician and inventor Blaise Pascal. 1837. First design for a programmable machine by Charles Babbage and Ada Lovelace. 1943. Foundations of neural networks established by Warren Sturgis McCulloch and Walter Pitts, drawing parallels between the brain and computing machines. 1950. Alan Turing introduces a test, the Turing test, as a way of testing a machine's intelligence. 1955. Artificial intelligence is coined during a conference devoted to the topic. 1965. ELIZA, a natural language program, is created. ELIZA handles dialogue on any topic. Similar is concept to today's chatbots. 1980s. Edward Feigenbaum creates expert systems which emulate personal assistance decisions of human experts. 1997. Computer program Deep Blue beats world chess champion Garry Kasparov. 2002. iRobot launches Roomba, an autonomous vacuum cleaner that avoids obstacles. 2009. Google builds the first self-driving car to handle urban conditions. 2011. IBM's Watson defeats champions of US game show Jeopardy! 2011 to 2014. Personal assistants like Siri, Google Now, Cortana used speech recognition to answer questions and perform simple tasks. 2014. Ian Goodfellow comes up with Generative Adversarial Networks, GAN. 2016. AlphaGo beats professional Go player Lee Sedol 4-1. 2018. Most universities have courses in artificial intelligence. This timeline reflects the evolution of AI from early philosophical ponderings to its current role as a transformative technology in the modern world. Time period. Landmark. Ancient times, philosophers like Aristotle contemplate the nature of reasoning and logic, laying early groundwork for AI concepts. 13th century Ramon Lull develops Ars Magna, a mechanical device aimed at generating knowledge through logical combinations of concepts. 17th century Thomas Hobbes suggests that reasoning could be mechanized, setting the stage for the idea of automated reasoning. 19th century Charles Babbage designs the analytical engine, a mechanical computer that could be programmed, offering theoretical foundations for computation. Early 20th century Alan Turing's work on computable numbers and the Turing machine provides a theoretical basis for modern computers and AI. 1940s Warren Michalak and Walter Pitts create a model of artificial neurons, inspiring future work in neural networks. 1943 Warren Michalak and Walter Pitts publish a logical calculus of ideas immanent in nervous activity, a foundational paper in neural network research. 1949 Donald Hebb's book The Organization of Behavior introduces the concept of Hebbian learning, which influences the development of neural network models. 1950 Alan Turing proposes the Turing test to determine if a machine can exhibit human-like intelligence. 1951 Christopher Strachey develops the first chess-playing program for the Ferranti Mark I computer. 1955 Alan Newell and Herbert A. Simon develop the Logic Theorist, a computer program that can prove mathematical theorems. 1956 John McCarthy coins the term artificial intelligence at the Dartmouth Workshop, a seminal moment for AI as a field. 1960s to 1970s, early AI research focuses on symbolic reasoning, with programs like ELIZA and Shadlu showcasing language understanding and problem-solving abilities. 1980s to 1990s, AI experiences periods of both excitement and reduced funding, known as the AI winter, due to unmet expectations and limited progress. 1997 IBM's Deep Blue defeats world chess champion Garry Kasparov, demonstrating AI's ability in complex tasks. 2000's machine learning gains momentum, with advancements in algorithms and computing power leading to breakthroughs in image and speech recognition. 2010s. Deep learning emerges as a dominant paradigm, employing neural networks with many layers to achieve impressive results in various domains. 2016 AlphaGo defeats world Go champion, showcasing AI's capabilities in strategic games and complex decision-making. Present AI is integrated into everyday life, powering virtual assistants, recommendation systems, self-driving cars, healthcare diagnostics, and more. Definition of artificial intelligence. These definitions offer a range of perspectives on what AI entails, highlighting its focus on replicating human-like intelligence and enabling machines to perform tasks that traditionally rely on human capabilities. Here are definitions of AI from various organizations in India and around the world. 1. Niti Aayog, India. Artificial intelligence is the ability of a machine to exhibit human-like intelligence by learning from experience and adapting to new inputs, enabling them to perform tasks that would typically require human intelligence. 2. European Commission. Artificial intelligence, AI, refers to systems that display intelligent behavior by analyzing their environment and taking actions with some degree of autonomy to achieve specific goals. 3. World Economic Forum. Artificial intelligence refers to machines that can perform tasks that would typically require human intelligence. 4. Stanford University. Artificial intelligence, AI, is the science of making computers do things that require intelligence when done by humans. 5. Indian Institute of Technology, Kharagpur. Artificial intelligence, AI, refers to the development of computer systems that can perform tasks that would require human intelligence. 6. IEEE Computer Society. Artificial intelligence, AI, is a study of how to make computers do things at which, at the moment, people are better. 7. Massachusetts Institute of Technology, MIT. Artificial intelligence is the field of study that focuses on enabling computers to perform tasks that require human intelligence. 8. United Nations Educational, Scientific and Cultural Organization, UNESCO. Artificial intelligence, AI, is a branch of computer science that aims to create systems capable of carrying out tasks that require human intelligence. Need of AI. In today's world, we have tons of data and complicated problems. That's where artificial intelligence, AI, comes in. It's like a super smart helper that can understand all this information, find important patterns, and even predict things. AI can do tasks by itself, help us make better decisions, and solve really hard problems. Whether it's in medicine, the environment, or just making things easier for us, AI is like a super tool that can make a big difference in how we use technology and solve problems. Here are some important points that suggest why we need artificial intelligence. Efficiency boost. AI streamlines complex tasks, enhancing productivity and efficiency in various industries. Data analysis. AI can swiftly process massive data sets, extracting valuable insights for informed decision-making. Automation. AI automates repetitive tasks, reducing human effort and enabling focus on creative and strategic aspects. Personalization. AI tailors experiences by analyzing user preferences, enhancing customer satisfaction and engagement. Healthcare advancements. AI aids diagnosis and treatment planning, leading to improved healthcare outcomes. Safety enhancement. AI powers self-driving vehicles and surveillance systems, enhancing safety and security. Innovation acceleration. AI fosters rapid technological advancements, driving breakthroughs in diverse fields. Scalability. AI enables systems to handle complex tasks at scale, making it vital for modern challenges. How AI works. Artificial intelligence, AI, works by simulating human intelligence in machines using algorithms and data. It involves the creation of systems that can perceive their environment, reason about it, make decisions, and take actions to achieve specific goals. AI systems learn from experience and improve their performance over time through a process called machine learning. This learning can be supervised, unsupervised, or reinforcement-based, allowing AI to recognize patterns, extract insights, and even adapt to new situations. Machine learning, a core aspect of AI, involves training models on large datasets to make predictions or decisions. For instance, in image recognition, a machine learning model is trained on thousands of images labeled with corresponding objects. Once trained, the model can accurately identify objects in new images it hasn't seen before. Another example is natural language processing, NLP, where AI models learn grammar and context from text data to understand and generate human language, enabling chatbots and translation services. Reinforcement learning is another crucial concept, often used in training AI agents to make decisions in dynamic environments. In a simple example, consider training an AI to play a game. The AI explores different actions, receives feedback, rewards for good moves, and penalties for bad ones. and adjusts its strategies to maximize its cumulative rewards over time. This approach is used in training self-driving cars to navigate real-world traffic scenarios. Overall, AI combines data, algorithms, and learning methods to create systems that can perform tasks that would require human intelligence, enabling automation, analysis, decision-making, and much more across various domains. The traits of human intelligence. Human intelligence is a complex and multifaceted trait that encompasses various cognitive abilities. These traits collectively define the rich and multifaceted nature of human intelligence, which goes beyond reasoning abilities to incorporate emotional understanding, social interactions, and ethical considerations. Here are some key traits of human intelligence. Traits. Description. Reasoning and problem-solving. Human intelligence involves the ability to analyze situations, identify patterns, and solve complex problems through logical and creative thinking. Learning and adaptation. Humans can acquire new knowledge, skills, and information from their experiences, and adapt their behavior and thinking based on new insights. Memory. Humans possess both short-term and long-term memory, allowing them to store and retrieve a wide range of information, experiences, and facts. Abstract thinking. Human intelligence enables the comprehension of abstract concepts, ideas, and hypothetical scenarios beyond the domain of immediate sensory experience. Creativity. Humans can generate novel and innovative ideas, solutions, and artistic expressions, often combining existing concepts in unique ways. Emotional understanding. Human intelligence includes the ability to recognize, understand, and manage emotions in oneself and others, forming the basis of social interactions and empathy. Communication. Humans can convey thoughts, ideas, and emotions through language, gestures, and various forms of expression, fostering effective communication. Self-awareness. Humans have a sense of self, allowing them to reflect on their own thoughts, emotions, and actions, leading to self-improvement and self-identity. Common sense. Human intelligence encompasses practical knowledge about the world, enabling individuals to navigate daily life using common sense reasoning. Intuition. Humans often make quick decisions based on gut feelings or intuition, drawing on their subconscious knowledge and experiences. Complex problem-solving. Humans can tackle intricate problems that may not have straightforward solutions, often involving multiple variables and trade-offs. Moral and ethical judgment. Human intelligence includes the ability to make moral and ethical judgments based on a combination of cultural norms, empathy, and reasoning. Adaptation to novel situations. Humans can apply their existing knowledge and skills to novel and unfamiliar situations, demonstrating flexibility in their thinking. Fundamental differences between human intelligence and AI. Human intelligence and AI exhibit significant differences, stemming from the contrasting nature of organic human cognition and artificial machine-based processes. Here are some fundamental distinctions. Key points. Human intelligence. Artificial intelligence. Origin and nature. Evolves naturally in biological organisms through evolution and neural networks. It's deeply intertwined with emotions, consciousness, and self-awareness. Designed and programmed by humans, based on algorithms and data processing. Lacks emotions and consciousness. Learning and adaptation. Learns through complex experiences, emotions, social interactions, and abstract thinking. Adapts to new situations by drawing on past knowledge and intuition. Learns from data through algorithms, improving performance over time. Adapts based on statistical patterns and programmed rules. Creativity and emotion. Displays creativity, imagination, and emotional understanding. Can appreciate art, create new concepts, and experience emotions. Lacks true creativity and emotional understanding. Can generate content based on patterns learned from data. but doesn't truly feel or understand emotions. Generalization can generalize concepts and skills from one domain to another, showing flexibility in thinking and problem solving. Typically specialized for specific tasks and lacks inherent generalization. Needs extensive training for different tasks. Common sense and context. Possesses common sense knowledge and contextual understanding, allowing for exact interpretation of situations. Lacks true common sense and often struggles with contextual understanding, relying heavily on the data it was trained on. Ethical and moral judgment. Makes ethical and moral judgments based on complex moral reasoning, empathy, and social norms. Lacks intrinsic ethical understanding. Can make decisions based on pre-programmed rules but without true moral consciousness. Self-awareness. Exhibits self-awareness, introspection and a sense of identity. Lacks self-awareness and genuine consciousness. While AI has made remarkable strides in matching certain aspects of human intelligence, it remains distinct due to its lack of emotional depth, consciousness, and the organic nature of human cognition. Pros and cons of AI. It's important to recognize that the impact of AI varies across different contexts and industries, and while it offers numerous benefits, careful consideration of its potential drawbacks is essential for responsible deployment and use. Pros of AI. Automation. AI automates repetitive tasks, freeing up human time for more creative and strategic endeavors. Efficiency. AI enhances efficiency by processing and analyzing large amounts of data quickly and accurately. Accuracy. AI reduces human error, especially in tasks requiring precision, such as medical diagnoses and manufacturing. 24/7 availability. AI-powered systems can operate continuously, providing services and information around the clock. Innovation. AI drives technological advancements and innovation in various fields, fostering new possibilities. Personalization. AI tailors experiences based on user preferences, improving user satisfaction and engagement. Data analysis. AI can process and identify patterns in vast datasets, extracting valuable insights for informed decision-making. Cons of AI. Job displacement. Automation by AI may lead to job loss in certain industries, potentially impacting livelihoods. Bias. AI systems can inherit biases present in training data, perpetuating unfair or discriminatory outcomes. Privacy concerns. AI's reliance on data raises privacy concerns, as personal information can be misused or exploited. Complexity. Developing and maintaining AI systems can be complex and costly, requiring specialized skills. Dependency. Over-reliance on AI may hinder human skills development and decision-making abilities. Security risks. AI systems can be vulnerable to hacking and malicious attacks, posing security risks. Ethical dilemmas. AI raises ethical questions about accountability, transparency, and the consequences of autonomous decisions. Types of AI. Based on capabilities. Artificial superintelligence. Artificial general intelligence. Artificial narrow intelligence. Based on functionality. Limited memory. Self-aware. Theory of mind. Reactive machine. 1. Narrow or weak AI. Narrow AI is designed for a specific task and lacks general human-like intelligence. Example, virtual personal assistants like Siri or Alexa. They can perform tasks like setting alarms, providing weather updates, and answering simple queries. 2. General or strong AI. General AI possesses human-like intelligence and can perform any intellectual task a human can do. Example, as of now, there's no fully developed example of general AI. It's a concept more in the field of science fiction. 3. Artificial Narrow Intelligence, ANI. ANI is focused on a particular task and excels in that domain but lacks broader understanding. Example: IBM's Deep Blue, which defeated world chess champion Garry Kasparov in 1997, showcasing superior chess-playing capabilities. 4. Artificial General Intelligence, AGI. AGI aims to mimic human cognitive abilities and understanding across diverse tasks. Example: AGI is still largely theoretical, without concrete examples in existence yet. 5. Artificial Superintelligence, ASI. ASI would surpass human intelligence and capabilities in virtually every aspect. Example: ASI is speculative and hypothetical at this stage, and no concrete examples exist. 6. Reactive Machines. Reactive machines operate based on predefined rules and lack learning or memory capabilities. Example: IBM's Deep Blue, which could analyze and predict chess moves but lacked learning from its games. 7. Limited Memory. Limited memory AI systems can learn from historical data to improve future decisions. Example: self-driving cars use limited memory to learn from past traffic patterns and adjust behavior. 8. Theory of Mind AI. This type of AI would understand human emotions, beliefs, intentions, and interact more naturally. Example: Theory of Mind AI is still largely in the realm of research and not practically realized. 9. Self-aware AI. Self-aware AI would have a sense of consciousness and self-identity. Example: self-aware AI remains a concept in philosophy and science fiction, without practical realization. Each of these types represents a different level of AI sophistication, from narrow task-specific systems to hypothetical advanced intelligences. Currently, most AI systems fall under the category of narrow AI. The domains of AI: artificial intelligence, data science, data, natural language processing, computer vision. Data science. Data. Data is a collection of raw facts which can be processed to make information out of it. The data can be in the form of numbers, words, symbols, or even pictures. In simple words, data science is a study of data. This data can be of three types: audio, visual, and textual. Data science is an interdisciplinary field that combines various techniques, algorithms, processes, and systems to extract meaningful insights and knowledge from data. It involves collecting, cleaning, and analyzing large volumes of data to uncover patterns, trends, and correlations that can inform decision-making and solve complex problems. Data science. 1. Collection and acquisition. 2. Storage datasets available in the institution's register. 3. Cleaning, preparing datasets for their users. 4. Integration, multiple datasets. 5. Analysis techniques and applications. 6. Representation and visualization. 7. Actions, managerial and policy implications. Data scientists utilize programming, statistical analysis, machine learning, and domain expertise to extract valuable information from diverse data sources. Data science is integral to extracting actionable insights from data, which can lead to improved decision-making, efficiency, and innovation in various fields like predictive analytics in e-commerce, healthcare diagnostics, climate change analysis, fraud detection in finance, social media sentiment analysis, enhancing sports analytics, building smart cities, genomic research, image and speech recognition, supply chain optimization, natural language processing, NLP. The ability of computer to understand human language, command, as spoken or written, and to give an output by processing it, is called natural language processing, NLP. Natural language processing, NLP, is a subfield of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language in a way that is both meaningful and useful. NLP involves the development of algorithms and models that can process and analyze text and speech data, allowing machines to extract information, derive insights, and communicate with humans in a language they understand. NLP continues to advance rapidly, enabling machines to better understand and interact with human language, opening up new possibilities for communication, analysis, and automation across various domains. Some of the important applications of NLP are sentiment analysis. To analyze text data from sources like social media, reviews, or comments to determine the sentiment expressed, positive, negative, neutral. Language translation. These tools can convert text from one language to another, enabling communication between people who speak different languages. Chatbots and virtual assistants. NLP enables chatbots and virtual assistants like Siri, Alexa, and customer service bots. Named entity recognition. NLP can identify and classify named entities like names, dates, locations, and more in a text. Speech recognition. This is used in voice assistants, transcription services, and accessibility tools for people with hearing impairments. Text summarization. This is useful for quickly extracting key information from lengthy articles or reports. Question answering. These systems find applications in search engines and virtual assistants. Language understanding in healthcare. It aids in extracting relevant medical information, supporting diagnosis and treatment planning. Computer vision. Computer vision in simple words is identifying the symbols from the given object, pictures, and learning the pattern and alert or predicting the future object using the camera. Computer vision is a field of artificial intelligence that focuses on enabling machines to interpret and understand visual information from the world, similar to how humans perceive and process images and videos. It involves the development of algorithms and models that allow computers to analyze, process, and extract meaningful insights from visual data, such as images and videos. Computer vision's ability to process visual information has wide-ranging applications across industries, from healthcare to entertainment, and continues to advance, with advancements in deep learning and image processing techniques. Some of its significant applications are object detection. This is used in self-driving cars to detect pedestrians, traffic signs, and other vehicles on the road. Facial recognition. It has applications in security systems, unlocking devices, and even tagging people on social media. Image classification. They can distinguish between different types of animals, identify plant species, or recognize everyday objects. Medical imaging. It helps doctors detect anomalies and diseases in patient scans. Augmented reality, AR. AR apps can display information about landmarks when the user points their smartphone camera at them. Automated quality control. Computer vision can inspect products on manufacturing lines for defects, ensuring consistent quality and reducing human error. Gesture recognition. It can recognize and interpret hand gestures, which finds applications in gaming, sign language translation, and user interfaces. Autonomous drones. They are used in various industries, including agriculture, construction, and surveillance. Retail analytics. It can track foot traffic, determine product popularity, and optimize store layouts. Security surveillance. Monitor surveillance camera feeds, detecting unusual activities or identifying potential threats in real time. Document analysis. It can process scanned documents, extracting text and information for digitization and data analysis. Art restoration. It can aid in restoring damaged artworks by analyzing images of the artwork and suggesting restoration techniques. Future of AI. The future of AI promises transformative changes across industries and daily life. As technology advances, AI will automate complex tasks, collaborate with humans to enhance decision-making, and address ethical concerns for responsible deployment. From healthcare to transportation, AI's evolution holds potential to reshape how we work, interact, and navigate the challenges of tomorrow. The future of AI will see the following. 1. Advanced automation will streamline industries and enhance efficiency. 2. Human-AI collaboration will augment professionals' capabilities. 3. Ethics in AI will be prioritized for transparency and fairness. 4. AI will revolutionize healthcare with personalized medicine and diagnostics. 5. Autonomous vehicles and drones will transform transportation. 6. AI-driven education will offer personalized and accessible learning. 7. AI will contribute to climate solutions and disaster management. How gamification uses AI? 1. Rock, paper, scissors data. In the context of AI, the rock, paper, scissors game can be implemented as a demonstration of how AI algorithms can make decisions based on patterns and probabilities. An AI-powered rock pile scissors game would involve training a machine learning model using historical data to predict the likely moves of a human player. The AI would analyze the player's previous choices and use that information to make its own move, aiming to outsmart the opponent. For instance, if the AI notices that the human player tends to choose rock more often than other options, it might choose paper to counter the expected move. Over time, the AI would adapt its strategy based on the changing patterns in the opponent's choices. This game is based on the data domain of AI. A. Open the link and try playing the game with AI. See if you can win. B. You can play the same game by opening the link too. You can even play by showing the symbols using your hand through your web camera. 2. Mystery Animal Game NLP. The mystery animal game using AI is an interactive and engaging experience. The mystery animal game using AI is an interactive and engaging experience that showcases how machine learning algorithms can guess the animal a player is thinking of by asking a series of yes or no questions. The AI algorithm narrows down the possibilities based on the player's responses, ultimately arriving at a prediction for the chosen animal. This game illustrates how AI can use a process of elimination and pattern recognition to make accurate guesses. For instance, if the player thinks of an animal like a giraffe, the AI might start by asking if the chosen animal is a carnivore. If the player answers no, the AI might ask if the animal has a long neck, and so on, until it deduces that the animal is likely a giraffe. The mystery animal game not only demonstrates how AI can make intelligent decisions based on user input but also showcases the fun and interactive ways in which AI technology can be utilized for entertainment and education. To play this game, open the link and asking questions and see whether you are able to guess the mystery animal correctly. This is a screenshot shows that after asking all 20 questions we couldn't figure it out that it was a skunk. 3. Emoji Scavenger Hunt Computer Vision. The Emoji Scavenger Hunt game using AI, subset computer vision, is a creative and interactive experience that combines emojis and machine learning. In this game, players use their smartphone's camera to find real-world objects that match specific emojis within a time limit. An AI model, trained to recognize objects, analyzes the camera feed in real time and provides feedback on whether the captured object matches the emoji. For example, if the player sees a bicycle and the corresponding emoji is shown on the screen, the AI uses image recognition to identify the bicycle in the camera feed. If the AI successfully identifies the object, the player earns points and progresses to the next emoji challenge. The Emoji Scavenger Hunt game demonstrates how AI technology, particularly image recognition, can bridge the digital and physical worlds in an entertaining and innovative way. It engages players by encouraging them to explore their surroundings while utilizing AI's ability to recognize and classify objects. To play this game, open the link and comment, try locating the objects as shown on the screen in the form of emojis. Vocabulary 1. Transformative. Causing a marked change in someone or something. 2. Trajectory. The curved path of an object that has been fired, hit or thrown into the air. 3. Disillusionment. A feeling of disappointment resulting from the discovery that something is not as good as one believed it to be. 4. Harnessed. To control the energy of something in order to produce power or to achieve something. 5. Ponderings. To think about something carefully or for a long time. 6. Contemplate. To think carefully about something or the possibility of doing something. 7. Hebbian learning. One of the first and also easiest learning rules in the neural network. It is used for pattern classification. It is a single layer neural network, that is, it has one input layer and one output layer. 8. Seminal. Original, important, and having great influence on future developments. 9. Unmet. Not achieved or fulfilled. 10. Strategic. Helping you to achieve a plan, giving you an advantage. 11. Perceive. To notice or realize something. 12. Penalties. A disadvantage or something unpleasant that happens as a result of something. 13. Cumulative. Increasing steadily in amount, degree, etc. 14. Multifaceted. Having many aspects to be considered. 15. Abstract thinking. Is the ability to consider concepts beyond what we observe physically. 16. Hypothetical. Based on situations that have not yet happened, not on facts. 17. Trade-offs. An act of balancing between two opposing situations, qualities or things, both of which you want and need. 18. Stemming. To stop something that is increasing or spreading. 19. Introspection. The process of thinking deeply and carefully to examine your own ideas, feelings, etc. 20. Organic nature. Things that are natural or related to nature. 21. Deployment. The act of moving something or someone into a strategic position or a position of readiness, or the condition of being in such a position. 22. Interdisciplinary. Involving two or more different areas of knowledge or study. 23. Transcription services. A business service that converts speech, either live or recorded, into a written or electronic text document. 24. Pedestrians. A person who is walking in the street, not traveling in a vehicle. 25. Restoring. To put something back into its former condition or position. 26. Scavenger hunt. Is a game in which the organizers prepare a list defining specific items, which the participants seek to gather or complete all items. Let's wind up. The history of AI dates back to the mid-20th century, with early attempts at creating machines capable of human-like intelligence. AI refers to the simulation of human intelligence processes by machines, including learning, reasoning, and problem solving. It's needed to automate tasks, analyze large datasets, and provide insights beyond human capacity. AI operates through algorithms that process data and learn patterns, often using neural networks and machine learning techniques. Human intelligence involves traits like creativity, emotional understanding, and common sense reasoning, which AI struggles to replicate fully. While AI can process vast amounts of data quickly and accurately, it lacks human qualities such as genuine understanding, empathy, and adaptability to diverse contexts. Its pros include efficiency, scalability, and the potential to tackle complex problems, but cons encompass job displacement, bias amplification, and ethical concerns. The future of AI holds promise in fields like healthcare, automation, and scientific research, but it also raises questions about ethics, regulation, and the nature of work as AI becomes more integrated into society. Narrow AI is designed for a specific task and lacks general human-like intelligence. General AI possesses human-like intelligence and can perform any intellectual task a human can do. AI would surpass human intelligence and capabilities in virtually every aspect. Reactive machines operate based on predefined rules and lack learning or memory capabilities. Limited memory AI systems can learn from historical data to improve future decisions. Theory of mind AI would understand human emotions, beliefs, intentions, and interact more naturally. Self-aware would have a sense of consciousness and self-identity. Data science is the study of data. This data can be of three types: audio, visual, and textual. The ability of computer to understand human language, command, as spoken or written, and to give an output by processing it, is called natural language processing, NLP. Computer vision, in simple words, is identifying the symbols from the given object, pictures, and learning the pattern and alert or predicting the future object using the camera. Computer vision is a field of artificial intelligence that focuses on enabling machines to interpret and understand visual information from the world. Gamification using AI involves utilizing AI algorithms to enhance game experiences, personalize content, and create dynamic challenges based on player behavior.